telescopes work? Telescopes are able to see things from an incredible distance, and to do this they must capture light. For a telescope to do this, it needs an optic, which is either a mirror or a lens. The bigger the optic, the dimmer the light it can see. The light is then concentrated by this optic, and that is the image that we get to see. These optics have to be near perfect to work properly. One scratch or smudge and the image can come out warped or blurry. It is very difficult to make optics perfect to use in a telescope, and a perfect lens is much harder to make than a perfect mirror lens telescope. A telescope made from a lens refracts light so we can see it. This makes the light magnified. The bigger and thicker the lens, the more powerful the telescope, so you can see things from further away that are less bright. Mirror telescope. A telescope that is made of mirrors reflects light so we can see it. Mirrors don't have to be thick like lenses, and instead bounce light off of a curved mirror into a flat mirror and into our eyes, instead of the refracting. Making telescope-worthy mirrors is also much easier than making telescope-worthy lenses, and mirrors are only one-sided, so they're easier to maintain. There are two mirrors in a reflecting telescope, and this is because the first mirror flips the image, and the second mirror reverts it back. Mirrors are also lighter, and therefore more easily launched into space, which is why the Hubble and Spitzer telescope are reflecting and not refracting telescopes.
Why some telescopes are put in space while others aren't. Telescopes are put in space for one main reason: to get a better, sharper quality image. For some astronomers, this is needed, but for other ground telescopes do the trick just fine. The reason ground telescopes can't take a good image is because of atmospheric distortion. When a telescope on Earth takes a picture of space, the light can be moved by the air in the Earth's atmosphere, making the light blurry. It's the reason stars seem to twinkle. Telescopes put into space can also detect the entire electromagnetic spectrum, while telescopes on Earth can't. This is because our atmosphere absorbs most of the ultraviolet and infrared light headed toward Earth. How telescopes see certain types of light. How to see invisible light. A human looking into a telescope can only see visible light. This is useful, however, visible light is only a very small part of the entire electromagnetic spectrum. To see the invisible light being gathered by our telescope, we need to swap out our human eye for different instruments. Infrared. To see infrared light, we use a normal reflecting telescope, and to detect the rays, we use an infrared detector, which can measure the intensity of the light. The problem with detecting infrared light is all the background infrared humans and objects both emit infrared light, which can be caught by the telescope. Also, water vapor in the atmosphere can also interfere with the infrared from space. To fix this, infrared detectors are cooled to minus 20 degrees Celsius, and infrared telescopes are put in high places on Earth. Some are even put into space to fix the problem of the atmosphere altogether. Microwaves. Microwaves are easier to detect than most other light because they are very long. Because of this, their wave can be picked up with metal parabolic collector, which is easier to make and maintain than a mirror telescope. The problem with microwaves is they can be absorbed by water, which may cut them off. It is how microwave heats your food. Radio waves. Radio waves are even easier to collect than microwaves, as they are bigger and less energetic. Even in poor weather, radio waves move fine, making them the easiest light in the electromagnetic spectrum to collect. Light with wavelengths shorter than infrared. For light with wavelengths shorter than infrared, they can be collected with an optical telescope. However, for telescopes on Earth, most of the light gets caught by the atmosphere, so to gather the light from the telescope, it must be in space. A spectrometer is a device that can measure different properties of light. The two types of spectrometers are spectroscopes and spectrographs. A spectroscope can transform light into a prism that can be seen through a telescope. A spectrograph is much like a spectroscope, but instead of seeing the light through a telescope, we use a detector. Spectrometers are very useful as we can use them to find chemical composition of different planets and stars. This can be used to see if there are planets like Earth with a similar chemical composition anywhere there in the cosmos. Spectrometers could lead to finding mankind's second home and maybe other intelligent life.
Hubble versus James Webb. The Hubble telescope and James Webb are very different telescopes. The reason they are pinned together is because the Hubble telescope was the next best thing at its time, and that's what the James Webb is. The Hubble gave us a look into space we had never had before, and mainly looked at optical and ultraviolet light, while the James Webb will be an infrared telescope. Not only are the types of light different for the telescopes, but so is the location. The Hubble is placed in Earth's orbit, which helps it take clear photos of the cosmos, while the Webb will orbit the Sun over 1.5 million kilometers away. The Webb telescope also has a much larger mirror, which will help it collect light from much further out. The James Webb telescope, having a much larger mirror, will also be able to see what scientists call baby galaxies, whereas the Hubble was only able to see toddler galaxies. Light is the fastest thing we know, but it still takes time for it to travel, and the James Webb telescope will be able to see light from millions and millions of years ago that is just reaching us now. It will help us understand the universe close to its beginning, and see visible light that over time has stretched and become invisible in the form of infrared. Looking back in time with light. Using light, we can actually look back in time. Light travels at an unimaginably fast 300 million meters a second. Even though this is incredibly fast, it still takes time for it to travel through space. The Andromeda Galaxy is the closest galaxy to the Milky Way. It is about 2.5 million light years away. Because of this, whenever we look at the Andromeda Galaxy, we see what it looked like 2.5 million years ago. We can use the same principle to look back in time to see what the early universe was like. As of now, we are unable to see what the first galaxies were like, because the light sent off by them is so incredibly dim that it has traveled a truly unimaginable distance. However, with the deployment of the James Webb telescope, we will be able to see some of the earliest galaxies that were formed, which will help our understanding of the universe and how it was created.
The history of telescopes. The two biggest historical figures in astronomy are Galileo and Newton. Galileo was not the first to create a refracting telescope, one could say, but he was one of the first to understand and to make it better. Galileo had a telescope that was able to magnify things 20 times, and with it he discovered that the moon was not smooth, but rather it was very rough. He also discovered moons orbiting different planets. He also noticed the weird appearance of Saturn, which later turned out to be because of the ring surrounding it. With his discoveries, he was able to say that certainly that the Earth was not in the middle of the solar system, but instead it was the Sun. The problem with being ahead of his time in science was people disliking and not believing his theories, and one of the biggest authorities against Galileo was the Catholic Church, who believed that the Earth was the center of the universe. The church and other groups called him out and called his beliefs a heresy, and to save his life, he had to publicly state that his findings were indeed incorrect. Newton's discoveries were monumental for not only astronomy, but for all of science. He wrote about the laws of gravity, which helped prove Galileo's point of the sun being at the center of our solar system. He was also one of the first to theorize about the fact that a different color light hits our eye differently, which refers to the different wavelengths and energy of visible light. He did all of that, and he was the first person to build a mirror telescope, helping to see further into space and expanding the field of astronomy.
Why space? Now you may be wondering, why do we look to space when we have so much problems on Earth? Well, according to Mark Rober, who's a former NASA engineer, we should be exploring space for 5 main reasons. 1. It makes the Earth a better place. 2. Extinction prevention. 3. It offshoots technology. 4. The economy. And 5. Exploration and imagination. 1. We can help to improve life on Earth. We send a large amount of satellites in Earth's orbit every year, and while some of them are to look into space and try to discover new things, many of them are sent up to help us down here. For example, GPS satellites are sent into space to help us figure out where we are on the ground. A GPS works by sending 3 satellites its signals and triangulating its location off of them. There are so many more satellites in space that are used to measure ozone, more accurately predict weather, detect and warn us about impending natural disasters, and so much more that we take for granted every single day. 2. Extinction prevention. No matter what humans try, the Earth will inevitably be uninhabitable due to the sun's explosion into a white dwarf, which will burn everything on the planet. However, the Earth will most likely be destroyed before that, whether due to an asteroid or due to humans with big weapons. Lots of missions in space are sent to try and find other habitable planets with water and oxygen, or to try to figure out how we could set outposts on other planets like Mars. These missions are very important as our time on Earth is most definitely limited, and the sooner we find other places for humans to call home, the safer we will ultimately be. 3. Offshoot technology. What this means is all of the unknown discoveries NASA and other space agencies make without attempting to. When discovering things, you may find advances in other technologies you didn't expect to make. For example, NASA set up a satellite to try and find what materials were under Greenland's ice caps, and they found one of the biggest craters on Earth. This helps us to understand the types of damage a large meteorite can do to our planet, while all the satellite was supposed to do was find the minerals under Greenland. 4. Economy. Space exploration creates a tremendous amount of jobs for some of the smartest people on the planet. The US alone spends around $22.6 billion on NASA, which helps so many people. Not only does it help NASA employees, but TV companies who bounce their signals off of NASA's satellite, or the weatherman on the TV telling you about the latest forecast. Satellites in space help so many. And 5. Exploration and imagination. To be human is to be curious. We have so many questions, and getting an answer to a long-standing question feels really good. Even if this space exploration takes us nowhere and we're destined to die on Earth, doesn't it feel good to know more about one of the greatest mysteries about living? The ever-expanding, ever-distant great beyond? We want to know more, and with space exploration we can. Plus, who doesn't want to see another Tesla in space?